So we're still talking about an ANOVA, which is a one-way analysis of variance. That means that we've got one independent variable and one dependent variable. When you're doing an ANOVA, there's always three things that you want to consider: significance, effect size, and power.
Significance, effect size, and power. Effect size.
Effect size.
Effect size. Effect size.
Effect size.
Significance, effect size, and power.
So today we're going to be talking about effect size, and that's actually eta squared and omega squared. So if you'll remember from last time, we've been talking about three groups of people, randomly selected, of course, to avoid bias, and they're getting different amounts of a made-up drug called statistoprazole. The first group gets nothing, the second group gets 10 milligrams, and the third group gets 20 milligrams. So this is our independent variable, what group they're going to go into. Our dependent variable is we're going to measure their scores on a test. And we're hypothesizing that perhaps the drug is going to help them do better on a statistics test. So this was the source table that we calculated out last time. By source, I mean sources of variance. So this is the between and the within variance. Remember, this is our error term, because when we're doing an ANOVA, we want the variance to come from between the groups. We're trying to prove that there's a difference between two groups. This would mean that the variance is coming from within the groups. So if this one group differs a whole lot, it's going to be very difficult to prove that it's significantly different from another group. This F value is our F obtained value. If this is significant, which we found it to be because we compared it to an F critical value at the alpha 0.05 level, this would tell us that we have a significant difference somewhere. We don't know where it is. It's somewhere in these groups. So then we went on to do planned comparisons between A1 and A3 and A2 and A3 to find out where the difference was. That ties into our significance. That means that we have a significant difference between the groups at the 0.05 alpha level, which means that if we were to run this test 100 times, we would get type 1 error 5 times out of 100. Now the second thing we're going to do is effect size. This means how big is your difference versus how sure are we that the two groups really are different. So we're still talking about effect size, which is how big is the difference between our groups, right? First of all, we did significance, which is how sure we are that we have a difference. At the 0.05 level, that means that we're very sure. 95 times out of 100, we have a true difference. Here we're looking to see how big that difference is. So these are the equations that you can use for omega squared, and you'll actually get the same thing. So all this information I'm taking from my source table. Sum squared between is this number. Number of groups of A, which is 3, minus 1 is 2. This is your error term, divided by the sum squared total, and the error term again. So, if you do that, get the same thing if you use this equation. You can use whatever equation you like. It really depends on whatever information you have that you're more comfortable with. But if you did the same thing, this F is just this F value right here, you would also get 0.443. Now, to interpret effect size, it's really arbitrary cutoffs. A lot of people have different ways of interpreting effect size, so you might want to check with your professor or your class or your actual textbook as to how you're doing it. But generally, this would mean that 44% of the variance in our study is accounted for by the groups.
This would mean that 44% of the variance in our study is accounted for by the groups.
Meaning between group variance. There's another way that you can calculate magnitude of effect in addition to omega squared, and that's called eta squared, and it looks like an R. So this, you just take the sum squared between groups divided by the sum squared of your total. That's also effect size, and that's interpreted the same way. So this is saying around 56% of the total variance in our study is attributed to what groups we put the subjects in. Now, if you'll notice, 56% of our total variance is a lot larger than what we got over here, which was around 44%. The reason is that eta squared tends to overestimate the magnitude of effect. Omega squared is a little bit more accurate, and if you look at the differences in the equations, this one takes into account your error term, whereas eta squared does not. However, for most purposes, and if you're using SPSS, eta squared is the accepted term. So this means that about 44% of the variance in our total study comes from just deciding which groups to assign people to. That means that the other percentage of the variance could come from within the groups, it could come from error, it could come from anywhere, but it's not something that's coming from what our groups are. Generally, this is a pretty large effect size, but the cutoffs could depend on whatever your professor or your book stipulates. Is my lipstick smeared?